Alright, how's everybody doing out there in Math Magic Land? This is Mr. Muscarella coming at you with my buddy L'Hopital. Check out his cool hairstyle. We're going to take a look at indeterminate forms and his rule. But was it really his rule? Or did he use his wealth to keep Bernoulli quiet during that time? Another thing in math history that is called into question. Anyway, let's move on and talk about indeterminate form. Now you should remember that when you're working with limits, indeterminate forms have to be 0 over 0 or infinity over infinity. There's these other indeterminate forms which we can use algebra skills to get them to be 0 over 0 or infinity over infinity. But a lot of times in textbooks, when students are working with L'Hopital's rule, they'll just L'Hopital's rule everything. And check out this example. This is a classic example of L'Hopital's rule gone wrong. So what did this person do? Check it out. Anytime, and you guys should know this at this point in your math careers, when you're evaluating the limit of any function, the first technique that you always want to apply is what? Direct substitution. So if we use direct substitution and evaluate cosine or x cosine of 1 over x as x goes to infinity, when we plug in infinity, well, we're going to have infinity for x. When we plug in infinity to 1 over x, that's going to blow up, as a lot of people will say. That'll just go right to 0. Because remember, the graph for 1 over x will end up approaching 0 as x goes to infinity. Because that graph, remember, looks like this, boop, boop. But as you're going to infinity, so you're going out here to the right-hand side, so it's getting closer and closer and closer to 0. So then we have just cosine of 0. Well, cosine of 0, you should remember that from your trig days, from unit circle, all that fun stuff. So you're going to have infinity times just plain old 1, and anything times 1 is just itself, so we're going to be left with infinity. Well, wait a second. That's not 0 over 0 or infinity over infinity. So that's not one of those indeterminate forms that we need. I pity the fool that don't use L'Hopital's rule correctly. So since this is not in one of those two forms, L'Hopital's rule does not apply. Peace out.